let's look at sketching of polynomials. So given this polynomial, the question is saying that sketch this polynomial. So the first thing you have to do, is to find the roots, okay, to the given polynomial. So how do you find the roots? You equate the polynomial, okay, x minus 2, x minus 1 to 0, equate it to 0, then find the values of x, okay, for these different factors. So it will be x plus 3 be equal to 0, x minus 2 equated to 0, and x minus 1 equated to 0. So the values of x will be, first we're going to have minus 3, then the second one will be x equal to 2, the third one will be x is equal to 1. So these are the roots of the polynomial. So what does it mean? It means that on the x-axis, okay, this polynomial here, this given polynomial here, is cutting the x-axis 1 at point number -3, second at this point here at 1, okay, at 1, the third point is at 2. It is cutting the x-axis at 1, at 3, at 1, and at 2. So for example, because 0 is somewhere here, if this is the y-axis, okay, this is the y-axis, this is the x-axis, this is the y-axis, and then 0 at the origin there. It means that this graph is either, okay, going like this, cuts here and then goes down, then goes up, comes out there, or it is moving like this, goes down there, goes there, and then cuts there. So between the two graphs, which one is the actual, is the correct answer here? Between the two graphs, which one is the actual answer? So number 2, you test using a table. Okay, you test these values. So how does testing using table work? It works like this. So we draw a number line first, okay, then indicating the values of x, of the roots. We have 1, then we have 2. So there will be values of x that are less than -3, then there will be those that are between -3, okay, and 1, then there will be those between 1 and this is to be x and 2, then there will be those greater than 2. So you investigate the behavior of this function in these regions for values less than 3, for values between less than -3, for values between -3 and 1, and for values between 1 and 2, and for values greater than 2. Okay, you investigate. So when, let's pick any value that is less than -3. Okay, so let's say 4 and substitute back in our given equation. So let's pick -4 and put it back in our equation and see what will be the value of the given function. So if you put -4, then you put it in the given problem, -4, -2, then -4, -1. Evaluating this, you get -1 here, here you get -6, then you get -5. So this is going to give you -30. Okay, so the interest here is the sign, okay, of this given function. The sign is negative, so this implies that this graph is below the x-axis. So it will be, so you write here below, okay, the graph will be below the x-axis. And from the two graphs that we've drawn here, you can tell which graph is below the x-axis for the values that are less than -3. It is the red one. So from here you can even conclude to say, oh, so my graph will look like this. Let's check further what will be the behavior of this graph for values between -3 and 1. -3 and 1. So let's pick any value. I would pick a 0 if I were you. So let's write it here. For x equal to 0, you find the value of, if you put 0 there, you're going to have 0 plus 3, 0 minus 2, and 0 minus 1. So you get 3, get minus 2, and you get minus 1. So you get positive 6. So positive is for above. So the graph between this interval is going to be above the x-axis. I'm using the red one, is just following what we're doing here. Just agreeing with it, whatever we're doing here. So this was supposed to be 0, is 0. So let's now check for numbers between 1 and 2. Let's pick 1.5. So for x between 1 and 2, let's pick 3/2, which is 1.5. So then check the behavior of the graph for this value. You get 3/2 plus 3. You get 3/2 minus 2. Again, you get 3/2 minus 1. So this is going to give you a 9/2. And this will give you a minus 1/2. And the other one is going to give you a 1/2. And if you multiply this, you get 9/8, negative 9/8. Okay, this negative here. So it means the graph is below in this interval, and indeed the graph, the red one, is below here. Then for any, you can pick any value that is greater than any value greater than 2. Let's create some space here. Create some space. So for x equal to, let's pick 3. It's the easiest one. So put your 3 there. You should get 3 plus 3, then 3 minus 2, then 3 minus 1. So you get a 6, get a 1 there, and you get a 2, positive 2 there, and you get a positive 12. So the graph for values more than 2 is above. Okay, and the red one just agrees with what we are finding here. Okay, so the actual graph will look like this. The final one, let's draw the final one now. So the final one should look like this. Okay, it should look like this. Okay, cutting, so you have to indicate these important points. At -3, then he is cutting. At what point? It's cutting at 1. This was 1. Okay, and also cutting at 2. In the graph f of x, then you have to show the x-axis, should also show the y-axis, and show the origin. And this is how to sketch a graph of the quadratic. But there's one key thing here. One key thing that I need to mention here is that for all, okay, functions with x power 3, okay, all cubic equations plus whatever follows, the shape will always be in this form. Okay, to start from this point, to start below the x-axis, and then wind and then end up above the x-axis. So to start from below the x-axis, start below the x-axis, and then end up above the x-axis. Let's look at the next example. We're looking at sketching of polynomial functions. So the first thing that you need to do for you to sketch a polynomial function is to find number one, find the roots of this polynomial. How do you find the roots? By factorizing the given polynomial, factorizing this. Okay, so let's find the factors of the given function f of x. So now how do you find the factors? We're going to use the trial and error method, where we'll be substituting the values of x, different values of x, beginning from positive negative 1, or positive negative 2, positive negative 3, positive negative 4. Okay, we'll continue doing this until we find the value of x that will give us such that if you put that value of x, we're going to get a 0. Okay, then it means for that value of x, say a, then x minus a is a factor, is a factor of the given function f of x. Okay, so we'll be looking for this value, okay, from among these values, the value of x, such that when you substitute in the given function, quadratic polynomial, we should get a 0. So let's start. We'll start from 1 or negative 1, then 2, positive 2 or negative 2. So let's say, for example, if x is equal to 1, what is the value of f of x? Okay, we're going to put f of x there. Putting f of x there, f of 1 here, we should have a 1 there. We should have a 1 there. So we're going to have 4, 1 cubed minus 8, 1 squared minus 1 plus 2. Let's evaluate this. We get a 4 there, minus 8 minus 1 plus 2. This is going to give us a 6 minus 9, so we're going to have minus 3. Okay, f of 1 is minus 3, so it means that x minus 1 is not a factor. It's not a factor. Okay, so we'll continue. Suppose now our x is negative 1. Suppose x is negative 1, so you substitute where there is x, you put negative 1 in the given polynomial. So we're going to have 4 minus 1 power 3 minus 8 minus 1 squared, then minus negative 1 plus 2, plus a 2 there. So this is equal to negative 4 minus 8 plus 1 plus 2. This is going to give us negative 10. This is going to give us negative 9. Okay, it's going to give us negative 9. So this means that x plus 1 is not a factor as well. Okay, so you continue investigating. Let's try suppose x is if x is equal to positive 2, so we check again f of 2 will be equal to, we have 4 2 cubed minus 8, then we have 2 squared minus 2 plus 2. So this is equal to 4 times, this is 8 minus, this is 8 times 4, then this will be 0 plus 0. This is going to be 8 times 4 is 32 minus 32, which is going to be 0. So this implies that x minus 2 is a factor of the given function. So if x minus 2 is a factor, we can find other factors of the given function by using any of the methods of dividing this factor into the given polynomial. So we have that x minus 2 is a factor of f of x. So we can find other factors by dividing f of x divided by, okay, we can find other factors. So we can use the long division, we can use also synthetic division. So let's use synthetic division. To use synthetic division, how does it work? How does synthetic division work? So you draw, you write in the format of synthetic division, okay, then here you put the value of x, which is 2, and then here you're going to write the coefficients of the given polynomial in descending powers of x. So the first coefficient is the given polynomial f of x is 4x power 3 minus 8x squared minus x plus 2. So we're going to write all these coefficients on this line here. So the first coefficient is 4x to the power 3, then there is x to the power 2 there, the coefficient is negative 8, then x to the power 1 there, the coefficient is negative 1, and the constant term is 2. After writing the constant term, you draw another closing line here. Yeah. So for the first term here, this first term, you just drop it, you write a 4 there, then you multiply 2 times the 4 there, 2 by 4, you get 8. So that 8, you write it here. Okay, then you add this negative 8 plus this 8, you're going to get a 0. So you multiply again, this 2 times 0 there, you get a 0. You put a 0 there, then minus 2 plus this 0, you get, sorry, minus 1 plus this 0, you get negative 1. When you multiply again this 2 times the negative 1 that you found, you get a negative 2, you write it here, then you add 2 minus 2, you get a 0. And if this was a factor indeed, you should always get a 0 here, because if x minus 2 is a factor, then the remainder is 0. So the new polynomial that you've come up with, let's call it the quotient polynomial, would be, it's going to have the coefficients 4, 0 and negative 1. Okay, and the highest power is going to be of x. There will be x here and then x there. The highest power here will be 1 degree less than the given polynomial here, one that less than the dividend polynomial. So the highest power here was 3, so 1 degree less it will be 2, 1, then the power here will be 0. So the polynomial, the quotient polynomial will look like this: x squared minus x, minus x minus 1, because x here is to the power 0, and 0 times x is 0, that's why we're going to have the x to the power 1 here. Now this means that we can write our given polynomial f of x as a product of its factors, which is x minus 2 and 4x squared minus 1. But when you look at this, it means that we can, when we look carefully at this, it shows that we can factorize this one further. Okay, so let's factorize this. Let's factorize 4x squared minus 1. This can be written as 2x squared minus 1. Then using the difference of two squares, we can have 2x minus 1 times 2x plus 1. So our given polynomial can be written as a product of its three factors, which is x minus 2, 2x minus 1, and 2x plus 1. Okay, so to find now the roots, f of x has to be equal to 0. So it means we should have x minus 2, 2x minus 1, and 2x plus 1 being equal to 0. Then equating each factor to 0. Okay, so we have 2x minus 1 equal to 0. We have 2x plus 1 equal to 0. So your x is going to be equal to 2, and then this x is going to be 1 over 2, and the other value of x is going to be minus 1 over 2. So these are the roots of the polynomial. So it means when you sketch this polynomial, it is cutting the x-axis on negative half, then it's also cutting it on half, and then also on 2. Okay, it's cutting the x-axis at these 3 points. So it is passing here, it goes down, and then goes up. Okay, so a quadratic equation will always an equation to the power 3 will always take this shape. Okay, so now actually sketching now this polynomial, we should have, first of all, you draw your x or y plane. Okay, not a perfect drawing, but we can deal with this. We can work with this for now. And the origin is there. Then here we have negative 1 over 2. Then we should have 1 over 2 somewhere there. Then we should have a 2. So the graph will pass through this point, through that point, and through that point. Okay, so the graph is going to look like this. It's going to pass here, down there, and then it should. So this is a sketch. Okay, it's not drawn to scale, but at least we are able to see the points where it's cutting, and then this is our actual graph. This is how it will look. I hope this has helped you to understand how to sketch the polynomial functions. Thank you for your attention.